Okay, today we're going to talk about templates in C++. So when we're building our containers, our data structures, it's fairly limiting to commit to a container's data type in the actual data structure. Okay, so we're gonna be creating this kind of vector clone called a safe array. And the safe array, the first version, I said, well, the safe array is going to hold only integers. So you, in your safe array int class, you had a int pointer, probably called something like p array. And we remember from the pointer lecture and the dynamic memory lecture, we use an int pointer because we want p array to point to this collection, this group of integers, and the safe array int class is going to kind of manage this container. Okay, but if that works out well, then we might want to also have a safe array. Okay, but this time of doubles, okay, or floats or whatever. And if that works out, we might want to have a safe array of students. So the safe array part of the data structure is it just maintains this collection of this array-based collection of pieces of data. They're all used to store an array of elements. The only difference between all of these is the data type that's being stored. So one's instinct might be to, once you have a working safe array int class, is to copy and paste it to make a safe array double class and a safe array student class. And if you did that, really the only change you'd have to make is anywhere there's a reference to the data type, right? If we wanted to have safe array of doubles, well, instead of having an int pointer, we'd have a double pointer. Right? So we'd copy and paste our code and replace every int pointer reference with a double pointer. And if we wanted to have a safe array of students, well, again, the type of the data that we're storing is a bunch of students, so we need a student pointer called p array. Okay. Now, templates allow you to defer committing to a particular data type until you get outside of the class. So let's look at a templated class here. First of all, notice the syntax is a little bit odd looking. So if we're going to have a class that is templated, we always begin the declaration of the class with this template class T. And then down here where we had a reference to a pointer, instead of having an int pointer or a double pointer or a student pointer, we use this generic type T. We say it's a T pointer. And T is going to get filled in later when we start actually creating these safe array objects. And we might have a method that returns, in this case, a reference to one of the underlying pieces of data. Again, we need to tell the compiler a type, but we're going to fill the type in later, so we refer to the generic T type. Okay. Now, when we want to implement a method in a templated class, again, syntax-wise, it's kind of funny. We always start the methods with template class T, and then anywhere we refer to the data type, so the data type is safe array, we now also have to put this T syntax here. This is going to take a while to get used to, but eventually you'll get used to it. This is the return type, and really all we're doing in the at function is making sure the bounds are valid. So the at function says, give me an index, and I'm going to tell you if that index is good or bad. If it's a bad value, we'll do something. If it's a good value, we'll just return the piece of data at position I. So notice the type, whether this is a safe array of ints or doubles or students, that doesn't really matter. The safe array data structure is just maintaining this array, this chunk of data. And it doesn't matter if it's an int or a double or a student. Okay, the last piece of the puzzle here is, well, we have to fill in the type somewhere. And we'll do that as soon as we create the object. Okay, so what this says is we want to create a safe array of ints. And what we're going to do is the compiler will go look at the safe array class, and replace every occurrence of t with this type int. And it will recompile and create a safe array of ints. And here what's going to happen is the compiler will go find the safe array class, replace every occurrence of t with a double, and compile off a new version. And here we're going to create a safe array of students. So imagine every place there's a t, it's going to be replaced with either int or double or student. And that's how we're going to basically be able to reuse this safe array class over and over again. And that's really the benefit of a template, is that you only need one copy of the data type. You only need one copy of the data structure, in this case safe array. And you can plug in the data type, and the compiler will go and compile off a new version of safe array based on that type. Now if there's a bug in your safe array class, you only have to fix it once. Okay, so the disadvantage of copying and pasting code is when there's a bug, you have to remember every single place you pasted it and fix it there too. So now the safe array, since there's only one of them, we only have to fix it once. Now if you're using a modern C++ compiler like Microsoft Visual Studio, there are some issues with templates. Okay, so there's some quirks, there's some problems with the way the templating functionality got implemented. So in order to deal with this, what we do is we're going to place an entire class in a single .h file. So normally what we've been doing is we've been separating. For every class we have a .h and a .cpp. For classes that have templates, and only for classes that have templates, we're going to put everything in the .h file. So this class here would all go inside saferay.h. So both the declaration of the class and the implementation of all the methods. And templates are going to be important for us in this class because we're going to talk about all these different data structures, and we want them to be generic. We want to be able to store inside our containers ints or doubles or students or whatever the user wants. Okay, and really the data type of the thing we're storing doesn't matter so much. We're going to be focusing on how the data structures work, and we want to be able to reuse the same data structures over and over again.